But I was asked by Ms. Fairbear, since I've just done it with my matrix, if I could, while I was still on parabola, just show you root questions. There's various root questions. A root, obviously, is where your graph cuts the x-axis. But what some of you might not have known is that it's a very common question where we can bring the nature of the roots. If you remember, the discriminant, some teachers refer to it as delta. Do you remember was b squared minus 4ac? The discriminant was sitting, if you were solving for your x, your roots, and you use the quadratic formula x equals minus b plus or minus the square root of, inside the radical, the square root is the discriminant, b squared minus 4ac. And then that numerator, if you remember, was all over 2a. That's the quadratic formula. So you've done nature of the roots, and the symbol is a triangle. The discriminant equals to b squared minus 4ac. So remember, if the discriminant was negative, you can't square root a negative, and that is why you'd have no real solutions for x. All right? If you look at this parabola, it's the same parabola in all three diagrams. It's a grade 10 parabola. Look, x squared plus 3. So it's happy, and it's cutting the y-axis at 3. This parabola has no roots. Look, the parabola is not cutting the x-axis at all. But we can use nature of roots in especially parabola, but other graphs as well that curve. I'd like to share this with you. So if they give you a parabola, look, the graph f is x squared plus 3 parabola because it's x squared. The graph g of x equals to 4x plus k. So it is a straight line linear graph because the x has an exponent of 1. But there is an unknown sitting there. Obviously, you could see it's cutting the y-axis there, but we don't know what it is. I called it k. I've drawn 3 scenarios. They might say solve for k. Do you see if the two graphs cut at one point, we would say the straight line f is a tangent to the parabola f. So the straight line g is a tangent touching the curve at one point. We often refer to that as tangential. So they might say if the graph f and g are tangential, that means they touch at one point. Now we're going to look at how we can use nature of roots to solve for this. The second case scenario is going to be if they cut in 2 different places, but I'm using the same straight line and the same parabola. And the third case scenario, if there's no point of intersection between the two graphs at all. So for tangential, where there is a tangent, straight line touches the curve at one point, your discriminant equals to 0. It's something you have to learn. If there are 2 different points of intersection, we'll say the discriminant will be positive. No point of intersection of your straight line and your curve at all, we will say the discriminant is negative. So this is just nature of roots in functions. So how you solve, guys, it's actually quite easy. What you do is, step 1, you let the one graph equals to the other graph, right? At this point, they are equal, so you take your parabola x squared, sorry, I just cut the squared off there, plus 3, you make it equals to the straight line graph, which is 4x plus k. Then you bring all the terms to the one side. I want it equals to 0. So we have x squared Now, just so you can see my shopping list, in the discriminant, which is b squared minus 4ac.
What'd you say?
Guys, there's too much noise on that side. Be quiet. Okay,
Which side,
so
ma'am?
do you agree? A is the coefficient of the x squared. So A would be 1. B is the coefficient of x. So that would be -4. And if you remember with nature of roots, C can be more than one term. And it just happens that C is going to be 3 plus K. So for those who have just tuned on, before we do analytical geometry, we're looking at nature of roots in parabolas, because it can be in any curved graph. Ms. Sam asked me just to quickly go through this. So we have a straight line, g of x. The equation is 4x plus unknown y intercept k. We have a parabola, grade 10 parabola, where it's f of x equals x squared plus 3. All right, so it's turning on the y-axis at 0 and 3. They touch at one point. That means tangential. F and G are tangential. And they might say, so solve for K. So step 1, you make the two graphs equal. Step 2, you bring everything to the left equals 0, get it into standard form, then go into your discriminant. So our discriminant must equals 0 for touch. So do you agree that B will be -4? So you take your B, but you square it, -4 times A, which is 1, times C, which is 3 minus K. And that must equals to 0 for tangential. So we've got a positive 16 here, and I'm going to multiply in, so we get -12. And then be careful with that minus times that minus. Do you all agree we get plus 4K equals to 0? Okay, so 16 minus 12 is just 4. So I've got 4K equals, I'm going to take the plus 4 to the other side, so it is -4. But we don't want to solve for 4K, we want to solve for K. So we'll divide by the coefficient, and you agree, everybody, I get K is -1. Now, you can see the y-intercept represented by K was there at, that will be 0 and -1. So I don't know if you've seen that before, but anyways, let's just move on. The exact same parabola.
Sorry, ma'am.
So the parabola I told you is F. Yes, I'm listening.
Ma'am, will you be sending these notes to us, or do we need to copy them?
No, at the end of the lesson, I will be forwarding the exact notes to you.
Okay,
so you can actually, you can just watch. Okay. So the parabola is the exact same parabola. F being f of x equals x squared plus 3. The straight line G is the same straight line. It's going to be 4x plus k. Now, k is going to be different now. The reason k is going to be different is the question is going to be, solve for k if there are two different places of intersection. That means where the two graphs connect, intersect. Now, to solve this, you must know your discriminant must be positive. But what you do, it's quite interesting. You still make the two graphs equals to one another, which we've actually just done that exercise. We get it into standard form. I'm just getting it in the right order. I think you can see that. And then your discriminant, which you know is b squared minus 4ac, must be greater than 0, must be positive. So the discriminant b squared minus 4ac must be greater than 0. B being -4 times a being 1, and c is 3 plus k. Greater than 0. Guys, you have an inequality here. So we have two terms, and remember to square the b. So b squared minus 4 squared, we're squaring the minus as well, is 16. Minus 4 times 3 is 12. And then that minus times that plus becomes minus 4k. Okay? This is, sorry, that was meant to be a negative. I was just looking here thinking, hang on, it should be exactly the same, because it's actually exactly the same. So I apologize. So we've got 4 plus 4k is greater than 0. So 4k will be greater than -4. We're dividing both sides by a positive coefficient of 4, which means the inequality stays in the same direction. Don't flip it, and you'll get the -1. So if we have 2 points of intersection, then even if my graph is not drawn, I know that straight line graph should have actually been drawn a little bit lower, but it's not drawn to scale, then k must be any value smaller than, greater than -1 for 2 points of intersection. Okay, so if -1 is there, any value bigger, and we will get 2 points. For no intersection, your discriminant must be smaller than 0. So again, you just equate your two graphs. We've done this. This is the third time. Get it into standard form. But this time, I didn't make the mistake of forgetting to bring the k over with the negative. Go into your discriminant, but make it negative. So to agree, we've got b squared minus 4ac is the discriminant, must be smaller than 0. So b is minus 4 squared, minus 4 times a times c, which is 3 minus k, and it must be smaller than 0. So we've got positive 16 minus 12 plus 4k must be smaller than 0. So 4k must be smaller, if you take it to the other side, minus 4. So k would be smaller than minus 1. Now, if you've done the exact same example 3 times, you can just see what's happening with the inequality. But it's an example, and I will be posting you this note, of a typical exam question that I've seen quite often in the grade 11/grade 12 exam. Let me show you an example. The algebra is going to be of a higher standard. So let me just erase this. The question came with no diagram. I will write the question on the board. So the question said, watch carefully. It said, question 2, let's just put that as question 2. If brand new f graph, so f of x equals to 4x plus k. Now that's similar so far, wasn't our other one 4x plus k? Yeah, but look, the parabola is totally different. So if that is a tangent to, now the g graph is going to be the parabola this time, and you'll see it's a totally different graph. It's a 11 parabola minus x squared plus 8x plus 20. So guys, it's a parabola because the degree of the variable defining it is a 2. There's a minus in front of the x squared, so the coefficient of the x squared is negative. So it's a sad parabola. We should all know that. So this is a straight line. The y-intercept is k, no diagram. And they say if the graph f is a tangent to this graph g, we're going to do 2 things. We're going to determine, they're going to ask me, let's say, determine 2.1. Will you determine k for 4 or 5 marks? That k. Okay. And the second question, 2.2, determine the point of contact. The point of contact. In other words, the point where the 2 graphs intersect. That would be about 5 marks. So this question could be 9 to 10 marks, and you might get it at the end of the year, but you never saw it. So just as well, we're having these Zoom lessons. So step 1, if you remember, just make the 2 graphs equal regardless and get it into standard form. So I'm going to bring the minus x squared to the left so it becomes positive. I have 4x. If I bring the 8x across, it's 4 minus 8, which is negative 4x. And I still have the k here, and bring the plus 20 across, minus 20 equals to 0. Guys, I'll just do the shopping list. You all agree a is your coefficient of your x squared. Do you see it is a ghost plus 1? B is your coefficient of your x term to the power. So do you see that will be minus 4? And C, the constant term, can be more than one term, and it is. It's actually going to be those 2 terms, k minus 20. All right? Now, if it's tangential or tangent, you know delta must equals to 0 for touch. So your discriminant, Okay, guys, suddenly it's got a bit noisy on your side. So just keep the noise down. Okay, so the discriminant, b squared minus 4ac, remember we've done this in term 1 in the algebra, must equals to 0 for touch, for tangent. So b is just minus 4, we're going to square that, minus 4 times a, which is 1, times c, which is k minus 20, it must equals to 0. So we have two terms. Let's simplify. Negative 4 squared we know is 16. Then you're going to have minus 4k. And then the minus times the minus becomes plus. And 4 times 20 is just 80. Equals to 0. So minus 4k is going to equals to, if we add 80 and 16, we get plus 96. So if we take that to the other side, we'll get minus 96. All right, now what we want to do is just divide both sides by the coefficient of the variable k so that we can solve for k. And the negative divided by a negative, the quotient, the answer to that division is obviously positive, and it goes exactly 24 times. So we've done the first question for, it could be 4 or 5 marks, depending on the examiner. So to solve for k, for the straight line to be a tangent to the parabola, 1 mark for equating them, 1 mark for standard form, 1 mark for subbing into a discriminant equals to 0, and 1 mark for solving for k. That would be my guess of the 4 marks. Now, in order to solve the second question, I'm going to have to erase this, but I'd like you to remember the graph of the straight line, the G graph in this example, the G graph, in this example is the parabola. It hasn't changed. I'll just rewrite it. But the F graph in example 2, we now have solved for k. So do we all understand that's why it's 2.2? In 2.1, solve for k, so we have f of x equals to 4x plus 24. Because we solved for the k in 2.1. So now I'm going to erase that. So the second question is determine that point of contact. Now remember, a point of contact is where the two graphs intersect. So if the one graph is doing that and the other graph is doing that, we're looking at what is that coordinate where the two graphs intersect. That's what we're doing next. And this is actually just simultaneous equations. So you make your one graph, let's look at the parabola, equals to the straight line, which we now know the y-intercept is 24. We didn't know that until we solved for k. And we're now going to solve for the point of contact. Okay, so we have minus x squared plus 8x, bring the 4x across, plus the 20 minus the 24. So we have minus x squared minus 4x minus 4. Now, if there's one thing I've told you guys, never try and factorize a quadratic trinomial that starts with a negative. So if you take out the minus 1, all the signs will reverse. And if you divide both sides by negative 1, you're left on the left side with the parabola like such, and 0 divided by minus 1 will stay 0. Now, if you factorize this, it's a perfect square trinomial. You'll get x plus 2 squared, which means x equals to minus 2. Now, I'm very happy I only got one solution for x. Because think about it, if these two graphs are tangential, I'm just saying, like so, then there is only one x value and one y value. So you wouldn't want to get two separate x values. So I'm very happy with that. Now, obviously, we've got the x. You always, with simultaneous equations, if it's a parabola and a straight line, which it is, you always substitute back into the straight line, not the parabola. Because when you square something in an equation in maths, it sometimes introduces a false solution. So we're going to go back to the straight line, f. We're going to replace x with minus 2, and we're hopefully going to find the y coordinate. So we're going to get minus 8 plus 24. So the y coordinate should be 16. Let me just see if I'm right there. 32. Hang on. Can I just go back? Either I made a mistake when I did it the first time.
Ms. Holmboe?
Yes.
Ma'am, 8x minus 4x is positive 4x.
Were you seeing this? Sorry.
The third line.
There. Okay, brilliant. Small, thank you. Sorry, that's a problem with live channels. Sometimes you make a mistake. So in this example, that's plus. So when I take out the minus, that's minus. It just means that is minus, and that means that is plus. Sorry, I made an error with my signs. You guys also do that in exams. I think it's the pressure of being put on the spot. So because I just did this example before we came online, and I remember the y-intercept was not what I had there. So if we make x2, which is what it should be, not minus 2, we'll get 4 times 2, which is 8, plus 24. That's better, because I have a memory trace that I've got the y coordinate to be 32. So the point where x is 2 and y is 32, that is the coordinate where my parabola intercepts the straight line. Being a tangent, we would only expect one coordinate. Okay, thanks for the correction there. Let me show you what else I quickly want to do with regards to roots and functions. I'm going to use a parabola. We looked at an example a little bit like this the other day. What I'm going to do is, before I use a parabola, so I'm actually going to take away parabola. Root questions, you don't always use the discriminant, but root questions in functions. Now, what I'd like to do to explain what I want to do is I'm actually not going to use a parabola. I'm going to use a different curved graph, but you guys don't know what this curved graph is at this point in your lives, okay? It doesn't matter which curved graph I use. It just so happens I'm going to use a calculus graph. But don't worry about that, okay? So you get to see what a calculus graph looks like before you hit grade 12. So this particular graph I'm going to draw, it's going to go through the origin and it's going to go like so. Not drawn to scale. So this, by the way, is a cubic function. I just want you to know cubic functions, just so you don't panic. We only do cubic functions in grade 12, and the form would be y equals ax cubed plus bx squared plus cx plus d. But you don't need to know that. I just want to show you a typical question. So the cubic functions have normally 2 turning points, 2 stationary points. I'm going to give you the coordinate of this turning point, 2 and 20. So not drawn to scale. When x is 2, y is 20. And let's just say this is the other stationary point B, 4 and 16. And the graph is f. Now, don't worry about what the equation of this graph is. But this is a typical question they sometimes ask you. Determine the values when they put the S in a bracket, it means you could get more than one value of k if the graph f, which, as I say, you don't need to worry the fact it's cubic, equals to k. And then I'm going to ask 3 questions. Has the first part of the question 2 distinct, sorry, not 2, I'm going to make 3 distinct roots. The second question, I will make only 2 distinct roots. And the third question, I'm going to make no roots. Okay. So we've got our graph. Again, you don't know which graph this is. It doesn't matter. Equals to k. And we want 3 distinct roots. Now, I did something like this the other day. Do you remember with this question? I said, put your ruler on your x-axis. Now, your x-axis is fine. It would also be where y equals to k. Now, if you look carefully, that this is my x-axis, it's only cutting this particular function in one place. So that is called one root. Now, we move the x-axis up and down. If I move the x-axis downwards, do you see it's also only going to cut? So let's pretend that is the y equals to -1 line. where k would be minus 1. You see, it's only cutting my graph in one place. And if I keep going in this direction, it's going to carry on just cutting my graph in one place to negative infinity. However, if I go to my x-axis, straight horizontal line up, to let's pretend not drawn to scale to where y is 1, all right? Do you see it's still only cutting the graph at one place, so we have one root. But finally, we patient. If we get to that value there, which you can see y is 16, because that's the y value of that coordinate. So if y is 16, k will be 16. Do you see that if k is 16, we have two distinct roots? Look, 1, 2. So that horizontal line, which is my shifted x-axis, is cutting my graph in two places. But we want initially 3 distinct roots. So look, if we go above where y is 16, so let's go there, for example, let's pretend that is 17. So if y is 17, that would mean k is 17. When k is 17, do you see we've got 3 distinct roots? Yay! That's what they wanted. But you can get 3 distinct roots if you go a little bit higher, even a little bit lower than that 16. But I think you can all see, when you get to where y equals to 20, which is this value of the y value of that turning point, do you see at where y is 20, which means k would be 20, do you see that my ruler is only going to cut the graph in 2 places? So there we're back to 2 distinct roots. And if I go higher than 20, for example, up to there, where let's say y is 30, do you see again we have 1 distinct root, and that will just keep happening to positive infinity. So if we answer these questions, for 3 distinct roots, you want your value for k to be between this value and this value. So remember, you put the smallest value on the left, the biggest value on the right, k in the middle, and don't include them. Most grade 11 seem more familiar with interval notation, where we go k is an element from 16 to 20, but use round brackets. And this interval notation is saying if k is bigger than 16 but smaller than 20, then we will have 3 distinct roots. For 2 distinct roots, I think we covered that. To agree, k would have to actually equals 16 or 20. Then we're going to get 2 cuts, 1, 2, 1, 2. So for 2 distinct roots, right, that would be 16 or k equals to 20. Okay, sorry. If you look at this, there's going to be no place. It's not applicable. Well, there'll be no roots, so they wouldn't have actually asked you that. So what I actually wanted to ask is just 1 root, only 1 root. So no roots, you can't get away from it. In this particular curve, just think about it. It's always, my ruler will always cut this graph in one place. So you would say it's not applicable for no roots, but for 1 root, do you agree that if we go below 16, right the way down to infinity, so if y is basically smaller than 16, there's another solution to get 1 root, where my ruler is just cutting this graph in one place. Do you agree that y would have to be greater than 20? But we're not doing y, we're doing k. So k must be smaller than 16, or k must be greater than 20. That will just give you the 1 cut. Some of you will prefer your other notation. So remember, the variable is k, not y. K is an element. So we go from the smallest, so minus infinity, which you will never reach, up until 16, which we're not including. Union meaning or, and then we're going from 20 up to positive infinity, but don't include either. So if k is an element in those intervals, we only get the 1 root. All right, so I hope that makes sense. So there are other questions. We don't have long. Today we're limited. We only have 5 to 6 minutes left. I'm going to bring back the parabola and I'm going to show you other questions they ask about roots in the parabola. I don't think I'm going to get to analytical geometry today, so I'll start that tomorrow. I might also not finish the question I want to do now, but I'm going to start it. So the parabola I'm choosing to draw, and remember I've made all these notes, I will just send them to you. So this is my Cartesian plane. Let's say the parabola, but please take note, guys, it is not drawn at all. Let's say the graph is F. So this is going to be the one x-intercept, and it's going to be negative 3, yeah, and 0. And this x-intercept here, B, is going to be positive 5 and 0. And let's call the y-intercept C, which is going to be 0 and 15. And they will tell you D is the turning point. Now, there was a whole lot of questions I wanted to do. I wanted to do 1.1, determine the equation of F. We've done this a lot. Okay, determine the equation of F for, let's say, 5 marks. Number 1.2, determine D, which is the turning point of F. And they would say the coordinates. I'm being a bit sloppy. I'll photograph it to you. That would be about 3 marks. So they want the coordinates of the turning point. And then after that, we're going to go into root questions. For example, 1.3, if f of x equals to k, determine k for f of x to have, let's say, 2 distinct roots. Okay, now, if we do get cut off, we've got 3 minutes, then I will maybe, I'll still post you the memo to this, but there were more root questions I was going to ask. So without a doubt, tomorrow I'm going to come back to this exact same question, but I won't redo whatever I did, but there are 2 or 3 more root questions I'd like to ask. Okay, very quickly, you have both roots, we have another coordinate. So to find the equation, we've done this 3 times now. It is a x minus your one root, x minus your other root. That's the formula. So in reality, it just means reverse the sign to get x, because minus minus is plus, and here you get x plus 5. If you remember, I've told you before, substitute another coordinate in before you do anything more. Put the 0 into the x's, put the y into the y. So 15 equals to a, nothing plus 3 is 3, nothing plus 5 is 5. Multiply that together, all right? And
Ma'am, why is x plus 5? Oh, yeah.
Reverse the sign. You know what? I picked that up for myself. Sometimes it's really, really good to make errors. Because you see, I can see minus 15a equals to 15. So a is going to be negative 1 if I divide. And I can see it's sad. Now, when I forgot to reverse that sign, I would have got a is positive 1. And I could tell in my head, because I was 1 minute or 1 second ahead of what I was writing, that I had made a mistake. But guys, I'm not a robot, as you can see, and when you're on the stage like this, it's a bit scary. But we have enough time to finish this. So go back to your a is minus 1, the 2 brackets, x plus 3, and I won't make this error again, reverse that root. Keep the line oil, so that you get x squared minus 5x plus 3 is minus 2x. There we get. So to get the equation of the parabola f, we times the minus 1, and we get plus 2x plus 15. I'm very happy about that, because did you notice the y-intercept is plus 15? 1 minute to go. Okay, the turning point, remember it's an x value, y value. Out of time, the quick method to get the axis of symmetry, if you add up the 2 x-intercepts and divide it by 2, 5 plus minus 3 is 2 divided by 2, so that is 1. And if you substitute 1 into the parabola, you will get the y value of the turning point. And I think we're running out of time, so I really can't do this too fast. So let's get a stay minus 1, because you're only squaring the 1, and then plus 1 plus 15, and something has gone wrong, so I vaguely remember it being 16. Can I please do this again tomorrow? There's a few errors in today's lesson, sorry. It's just that it's really hard to do this online. Guys, I will get that. You can do it in the meantime. X is 1, and I remember, because I've done this question before, I just want to make sure if I got that right. Minus 1, the parabola is definitely correct. There was a 2 there. Okay, that is why it is going to be 16. Okay, so the coordinates of D is 1 and 16. All right, so now tomorrow I'm going to do the root question, followed by 2 other root questions. All right, so we're just carrying on with roots and functions, and then after the root questions, I'll come back to this diagram. We go on to analytical geometry. Thanks, guys.